Welcome to the second installment of the video of the week. In this video of the week, we'll be talking about what you should be doing right now. I'll be giving you some notes about domain because those can be pretty tricky problems. And we'll talk about how to find the equation of the line between 2 points because students tended to struggle on that problem on the final exam. So first off, what should you be doing right now? Well, you should be registered at mymathlab.com as soon as possible. I noticed that most of the classes have already done that, so if you haven't, please do it now and get started with the class. To do that, follow the instructions in the email I sent you previously. Second, you should be working on the Chapter 1 homework assignment. When you log into the course itself, you'll notice that the first page that comes up is right here. If you want to work on the first chapter's homework assignment, just click that link right there. Start working on problems and let me know if you have any questions. Okay, let's talk about domain. So two main things that you want to know at this point in the course about domain. Typically what you'll be asked is to find the domain of some function, and you'll be given some function. Two things you're looking for. One, you're going to have restriction on domain if you have a denominator in your function. More specifically, the denominator in your function cannot equal 0. If you had an example, say like g of x is 1 over x minus 2, that x minus 2 is your denominator, and we know that that cannot equal 0. So x minus 2 cannot equal 0. Well, if we add 2 to both sides of this thing, we get that x cannot equal 2, and that is the restriction on your domain. And all that means is you can't plug x equals 2 into this function and get an answer. Because if you plug x equals 2 into this function, you get a 0 in the denominator. Okay, now if you want to communicate this idea with someone that x cannot be 2 in your denominator, there's two ways to do it. There's set notation and there's interval notation. In this case, set notation is pretty simple. It looks like this. These are sort of the curly brackets on the outside, and what this means is the set of all x values, the vertical line means such that, and then x is not equal to 2. So what this means is x could be any number other than x equals 2, and it would be part of the domain of this function because you can plug any number into this function except for x equals 2. Interval notation is just another way to say the same exact thing. And when I think of interval notation, I think of an actual interval. I draw it out here, 0, 1. And what I think is I can plug any x value I want into that function except for x equals 2. So the domain of my function is everything from negative infinity all the way up to 2, and then everything from 2 all the way out to infinity. I'm going to write out those two intervals, negative infinity to 2, and 2 all the way to infinity. Notice I'm not including negative infinity, and I'm not including 2 in my interval. And the way we combine these two intervals is with what we call a union. So this example that turned out to be actually fairly long is asking you to find the domain of g of x, which is this function right here. And there are two possible answers. If you're asked for set notation, this is your answer right here. If you're asked for interval notation, that's the answer right there. Okay, so that's one example. Another thing that you want to know about domain in this chapter is that you can't have a negative under a square root. You've learned from some math class in the past that if you have a negative number under a square root, that it's not a real number. If I want to be a little bit more technical about this, technically there is a 2 here, that's why it's a square root. We don't write it typically. If there was a 3 here, it would be called a cubed root, and it doesn't matter if there are negatives under a cubed root. However, if there was a 4 here, you can't have a negative under a 4th root either. So the general rule to follow here is that you can't have a negative under an even root, an even number root. Cubed root and 5th root and 7th root, those are all okay, but if you have an even number here, you can't have a negative number under that. So let me give you an example real fast. A common example would be something like this. There's a square root, it's an even root, and you have something under it. Well, we know that that can't be negative. So that thing right there has to be positive, or it could equal 0. If we subtract 4 from both sides of this, we get that x has to be greater than or equal to negative 4. What this means is I can plug any x value into this function that I want as long as x is greater than or equal to negative 4. Why? Well, if I picked a number that was less than negative 4, I would get a negative under my square root, and that's not a real number. So that x couldn't be part of our domain. Okay, let's write this answer out in both set notation and interval notation. Set notation is the same as before. It's the set of all x values such that x is greater than or equal to -4. And that would be your answer if you were asked for set notation. For interval notation, I always like to draw a little picture. If we draw out all of the numbers on this interval that are greater than or equal to -4, we get something like that. We only have one interval here as compared to the last example where we had two intervals that were separated. So our answer in this case is just -4 out to positive infinity. Make sure that you include the -4 in this example because of the equal sign here. What that looks like in interval notation is this right here. Okay, so let's recap. If you're asked a domain question, if you're asked to find the domain of a function, you're looking for two things, denominators and even roots. If you see yourself with a denominator, you need to make sure that that denominator cannot be 0. If you have an even root in the problem, you need to make sure that whatever is inside of that even root has to be greater than or equal to 0. Okay, I hope that helps with that problem. One more problem I'd like to talk a little bit about, which is very common in this class, is finding the equation of a line between 2 points. I'll make up an example. Let's say we want to find the equation of a line between those 2 points right there. Well, in order to find the equation of any line, we first need a slope. And you have a formula for a slope in your book. Some people think of it as rise over run. It's the difference between your y values divided by the difference between your x values. Gives us that our slope in this example is a fraction, and it's -10/9. Once you have the slope and a point, either point works, you can plug these two things into point-slope form or slope-intercept form to finish off the equation of your line. I'll show you the point-slope form way to do it. There's the point-slope formula right there. What we're going to do is take either point that you'd like. I'll choose the point -2, 4, and we're going to plug that with our slope into this equation. You'll notice that the y itself and the x variables have to stay in the equation. We need those for the equation of a line. And then I'm going to do a little bit of algebra. I'm going to distribute the 10/9 through the parentheses. And then we're going to get y by itself, because typically getting y by itself is the form that we'd like our line to be in. Now the only thing we have left to do is to combine the 29ths with the 4. So I'm going to take a couple more lines to do this. What we need to do is find a common denominator between this 4, or we can think of it as 4 over 1, and the 29ths. The way that we do this is we multiply this by 9 over 9. That's going to convert the 4 into 36/9, and now we're allowed to combine these two fractions together. And we get the final answer for the equation of the line that passes through the 2 points that I made up here. That final equation is y equals -10/9 x plus 16/9. Okay, so hopefully that was a hard enough example for you to get something out of it. Just as a recap, what you should be doing right now is making sure that you're registered for mymathlab.com. And you should be working on that Chapter 1 homework so that you can be sending me questions and getting ready for that quiz. That is due pretty soon. And hopefully you learned a little something about domain in this video, and hopefully this example of finding the equation of the line between 2 points helped you out a bit. Let me know if you have any questions, and I'll see you in the next video.